Hello friends, now I am going to discuss fast shifting theorem in Laplace transform, and using that fast shifting theorem I will solve some problems. Let's start. So what is the statement of fast shifting theorem? That if Laplace of f of t is equal to f of s, wherever means where s greater than k, then Laplace of e to the power at into f of t, that means when I multiply some exponential function e to the power at with f of t, then its Laplace will be f of s minus a. That means s will be shifted by s minus a. So sometimes this fast shifting theorem is also called s shifting theorem. It is also called s shifting theorem, right? So now this formula we have to remember, and suppose if we take its inverse on both sides, then also we can write like this: e to the power at into f of t will be Laplace inverse of s minus a. Okay, now if we want to prove this, then suppose take its right hand side f of s minus a first, then what we will get? So f of s minus a. So what we can write for this, because we know that from the definition that what is the definition of f of s? F of s means we took what? Laplace of f of t. F of s means we took Laplace of f of t, and by the definition of Laplace of f of t we know that it is integration of e to the power minus st into f of t dt, and limit will be 0 to 0 to infinity. Okay, this is the definition for f of s, that is Laplace of f of t. So for f of s, note that f of s, here it is s. So when we took f of s, the integration is from e to the 0 to infinity e to the power minus st. Note it is s. When it is s, and the integral also it is s. So we have to write f of s minus a. So therefore we have to write what? In place of s, it will be s minus a, because here we took f of s minus a, right? So it will be 0 to infinity e to the power minus s minus a whole into t f of t dt, by this definition. Okay, now if I multiply this s minus a with t, then it will be what? E to the power minus st, then e to the power 80. You know that, because minus minus plus, so e to the power 80, here e to the power minus st. So now if you compare with the definition of Laplace of f of t, here e to the power minus st, and in place of f of t, here it is e to the power 80 into f of t. In place of f of t, here it is e to the power 80 into f of t. And just you compare with the definition of Laplace, then what we can write? Whose Laplace transform will be this? It will be Laplace transform of e to the power 80 into f of t. Laplace transform of e to the power 80 into f of t. Okay, so this is your left hand side. This is your left hand side. Okay, so this is the proof. Now see some problems. First example, that what is Laplace transform of t into e to the power 2t. So see here, if you compare the fast shifting theorem statement, so what is the statement? If Laplace of f of t is equal to f of s, then Laplace of e to the power 80 into f of t will be f of s minus a. This is the statement. Now, so if I found Laplace of f of t, if I can get Laplace of f of t in form of f of s, then Laplace transform of e to the power 18 to f of t can be written as f of s minus a. That means if I get f of s, then to find Laplace of e to the power 18 to f of t, only s will be replaced by s minus a. Is not it? Okay. So, keeping in mind this statement, try to solve these problems. So here, if you compare this, e to the power 18 to f of t, so here e to the power 2t into t, e to the power 2t into t. Now, f of t, so if I get Laplace of t, then we can find Laplace of t into e to the power 2t. So therefore, first I have to find Laplace of t, and that is nothing your 1 by a square. 1 by a square. Now, to find Laplace of t into e to the power 2t, because e to the power 2t is multiplied, that means we have to note that the s will be replaced by s minus a. So what is a here? E to the power 2t. E to the power 2t. So our a is 2 here. So therefore s will be replaced by s minus 2. So s is replaced by s minus 2. So the result is what? 1 by s minus 2 square. Clear? Similarly, if you solve Laplace of e to the power 2t into sine 3t, Laplace of e to the power 2t into sine 3t. Okay, so if I want to solve Laplace of sine 3t, then we can find Laplace of e to the power 2t into sine 3t. Now, according to our formula, we know that Laplace of sine 3t is 3 by s square plus 3 square. Now, if I multiply e to the power 2t with this, so Laplace of e to the power 2t into sine 3t, how to find this? This s will be replaced by s minus a. And what is a here? Again 2. So, s will be replaced. This s will be replaced by s minus 2. The result will be what? 3 divided by s minus 2 square plus 3 square as usual. So only you have to check where is s, and that s should be replaced by s minus a, and a is what? That is in the power of exponential e. Is not it? E to the power 2t. So coefficient of t in the power of e. Coefficient of t in the power of e. So therefore, the answer is what? 3 by this. Similarly, you can find also e to the power t into cos hyperbolic 2t, Laplace of e to the power t into cos hyperbolic 2t. The same thing, find Laplace of cos hyperbolic 2t first. And what is this? S by s square minus 2 square according to formula. S by s square minus 2 square. And since here it is e to the power t only, what is a here? Means coefficient of t, that is 1. That is 1. So, the s, wherever it is s, we have to replace it. Okay, so s, again s, in numerator is also there is a s, in denominator there is also a s. So therefore, s will be replaced, every s will be replaced by s minus 1. So s will be replaced by s minus 1 because a is 1 here. Then again, here it is s, so s minus 1 whole square minus 2 square. So the result is what? S minus 1 divided by s minus whole square minus 2 square. So in this way you can solve your Laplace transform of e to the power 18 to f of t like question. Okay. So again, now we will solve some inverse problem using fast shifting theorem. You just see that Laplace inverse of 1 by s plus 1 whole square. How to find Laplace inverse of 1 by s plus 1 whole square? So just recall the statement of fast shifting theorem that Laplace of e to the power 18 to f of t is f of s minus a. and if you take inverse on both sides, then it will be Laplace inverse f of s minus a, and it will be e to the power 18 to f of t, where f of s is Laplace of f of t. Clear? So to solve this Laplace inverse of 1 by s plus 1 whole square, just suppose it is only a square, not s plus 1 whole square. It is, suppose it is only 1 by s square. So since it is 1 by s square, so whose Laplace transform is 1 by s square? It is t, so just write t. Now since it is s plus 1, then we have to multiply e to the power minus t, because s will be replaced by s minus a. So since it is plus 1, so we have to multiply e to the power minus t. Clear? Suppose the question would be 1 by, means Laplace inverse of 1 by s minus 1 whole square. S minus 1 whole square. So what will be the result? The result will be t into e to the power plus t. Okay, so since it is s plus 1 here in our question, the result will be t into e to the power minus t. So similarly, try this question again. Try this question. So Laplace inverse of 3 divided by a square plus 6s plus 18. A square plus 6s plus 18. Now to solve this, just rearrange the denominator like this, a square, then for 6s just write 2 into 3 into s, you can write like this, then for 18 3 square plus 3 square. Now you can see the first three terms will give what? It is s plus 3 whole square, s square plus 3 square plus 2 into 3 into s. So this is your s plus 3 whole square, is not it? Then the rest part is plus 3 square. Now see, to find Laplace inverse of this term, it looks like, it's just see the bracketed term, it looks like what? Whose Laplace transform will be like this, in this form. You just recall the formula, 3 by a square plus 3 square. A square plus 3 square. This is like this, but in place of s, it is s plus 3. This is the only extra thing, but this bracketed term looks like this. So just see, same process, try to suppose this is not s plus 3, it is only a square. This is not s plus 3, it is only a square. So this will be obtained 3 by a square plus 3 square. So this is Laplace inverse of 3 by a square plus 3 square. Okay, so whose Laplace transform is 3 by a square plus 3 square? We know that this is sin 3t. This is sin 3t. Now since it is not only s, it is s plus 3, so we have to multiply exponential function, as you means from your from the definition of fast shifting theorem. So the result will be what? Sin 3t into e to the power minus 3t, because it is s plus 3, so we have to multiply e to the power minus 3t. So the result is e to the power minus 3t into sin 3t. Clear? Is it okay? So like these examples, try yourself to do some more examples, some more problems using fast shifting theorem, so that it will be more clear. Okay, so again we will meet in the next lecture. Thank you all.